G'day everyone, my name's John Groves and I'm here to give you a brief presentation on the global iron ore industry. I guess I'm going to touch a little bit on the geology and metallurgy and some plant processes as well. Hope everyone's got their coffee or their healthy rooibos tea as you're about to get bombarded with lots of big numbers. Presentation will cover the demand, the production, world prices, global resources, a bit on geology and ore types, the commodity, what to use it for, and some of the processes. And I've even touched on a few major projects which are still happening, about to happen in Western Australia. First off, as all good sellers know, you've got to start with your client and your customers. So your customers here is the global demand of imported iron ore, and you can see on this chart where China is hugely dominant at 1,333 million metric tons. Yep, that's 1.03 billion tons of ore. The whole global imports estimated at 1,540 million metric tons. That's 2019 figures. But 2020 I just received was 1,600 million tonnes, so a slight increase from 2019. Who supplies all this? Well, seaborne trade of iron ore. The exporters are Australia at nearly 900 million tonnes down here. Brazil is next at 330 million tonnes. And third on the list is your country in South Africa, with 61 million tonnes in 2019, which I believe went to about 67 million tonnes in 2020. Here's another graph of the presentation in a slightly different way, showing it as a bar chart where, as you can see on this, the 900 million tonnes from Australia, which is basically the Pilbara, dwarfs even Brazil, the second one, at 400 million tonnes. Interesting to note, China and India and Russia all produce iron ore, but most of it is used internally for their domestic steelmaking. Another slightly different chart of the same thing where the global iron ore producers shown is calendar year 2010 and calendar year 2020. And most of the countries, you can see the light blue graph and the dark blue graph are very similar. A few increases along the way and a few decreases, but this is the big one. Australia went from just over 400 million tonnes in 2010 to 2020, where they're producing 900 million tonnes, more than double. And this is due to the expansion, obviously, in the Pilbara in the last 10 years. The demand for iron ore, and this is just a chart of Asia because Asia is obviously our closest region and we don't send much to Europe these days. But basically in Asia from 2000 to 2020 there was a rapid increase, and the blue bars here are obviously China. Japan, South Korea, Taiwan all contributed to that, of course. And as you can see, the peak there is over 1.6 billion metric tonnes, 1.6 billion metric tonnes. It's forecast in the next 30 years to 2050 that China will drop off to about 615 million metric tonnes. Japan, Korea, Taiwan drop a little bit, but then the rest is taken up by Asia, which is India and Vietnam and the whole of Southeast Asia area. So it still will maintain, we believe, at this 1.5 billion metric tonnes a year. World iron ore prices over the last 12 years, from 2010 to 2022, you can see that there's huge, wild fluctuations due to different world crises and supply and demand issues. Suffice to say, the lowest was here at $39 US dollars per dry metric tonne. This is CFR China for 62% Fe iron ore. And the highest was a record set last year at $229.50 a dry metric ton. So the distant past was last 3 years, where we held over $100 US for dry metric ton. Most of the last 3 years, there's a little dip here where it went to $92 a ton in November last year, but it also includes the record of $229 a ton. So the average iron ore price over this 3 years is $156 US per dry metric ton. Last week, for example, was running at $140 US per dry metric ton, and we expect to hold over $100 per dry metric ton for the next couple of years. Cost of production. Yes, this is an interesting graph I found, and it's really about your operating cost and the cost to produce it in US dollars per wet metric ton FOB. You see the bottom three producers here, India, West Australia and Brazil, all under the average of 45 US dollars per wet metric ton FOB. South Africa's not too bad, just slightly above average, but that's a good unit cost. Of course, freight is a big part of this cost, and in Western Australia it's about $11.40 per wet metric ton, whereas Brazil is double that at $25 per wet metric ton, and these are January 21, September 21 figures. The other thing on pricing is fines versus lump. And you can see the average iron ore price in 2019 for fines in these green bars, and red or orange for the lump. If you compare the 62.5 Fe lump with the 62 Fe fines, there's about $17 dry metric ton CFR China difference in these two. The reason for that, of course, is you can charge iron ore lump directly into the blast furnace, and you skip a stage where, as in fines, you have to pelletise or sinter the material to produce a lump. So all the fines that are produced need to be put back together again in lump form, as you can see from these photos. This is a Brockman ore, this is a Maramamba ore, and basically the chart on the left you can see about just over 200 million tonnes of lump is traded, seaborne trade that is, on the world market, and both Australia and South Africa contribute to that, obviously Australia being the dominant lump producer. This little calculation gives you the formula for the $17 a tonne difference, but basically if you can produce an extra 1% lump from your mine, it puts another $30 million US into your bank. Resources. This shows the global resources of the key countries and ore types. Hematite is by far the dominant iron ore resource in the world, and you can see Australia is over 770,000 million metric tonnes. This is on a basis of 62% Fe, of course. Brazil is next at 30,000, that's 30 billion tonnes, but not even half the Australian content. And you can see the rest slides down with their magnetites and the yttriterites. Another interesting way of presenting this was the West Australian iron ore resources. West Australia has estimated they've got just under 50 billion metric tonnes of economically demonstrated iron ore resource in 2020-21. When you plot this up on the current use of 2021 rates at 900 million tonnes a year, it's going to last for 56 years. So well and truly see out my career. I guess if you're a mining supplier, both of equipment and or process parts, it's obviously the place to be. Just another little brief history I found for Australia, for those who are interested, is that we really didn't kick off our industry till the mid-60s, when the export ban of iron ore was lifted by the government. We then were able to supply Japan, the industrialisation area, with about 100 million tonnes a year to the 80s. Between the 80s and the 90s was the development of South Korea and Taiwan, where we put another 100 million tonnes into the market, and then the China boom came along, and as you can see, this is an exponential growth curve, lifting up, flattening off a little bit at the current time in 2018-19, but even today in 2020, we're hit over 900 million tonnes per annum of iron ore export. Geology 101, I was asked to give a little bit of this. So basically, iron ore deposits are typically found in sedimentary rocks. 1.8 billion years ago, they formed by the chemical reaction of iron and oxygen mixed in a marine and freshwater environment. The minerals that were produced then became embedded in layers on the ocean floor and formed a banded iron formation, or we commonly call BIF, which has alternating layers of either silica or shale, or both, and iron ore. This particular picture here is showing a BIF, banded iron formation of hematite and jasper. Also, for good measure, I threw in the common iron ore minerals, and a lot of you can see or know that the hematite, Fe2O3, is a touch under 70% iron, or Fe. Magnetite, the next common mineral, is Fe3O4, and it's just over 72% iron. And then you've got your limonite, which is also your goethites, and they have 3 H2Os typically attached to the Fe2O3, chemically combined. And then some siderite, which is your carbonate of iron. The other interesting thing I threw on this page was how they formed channel iron deposits. Basically, it's the pisolithic iron ore in the Pilbara area, West Pilbara, with the Yandy-Coogin you may have heard of, with both BHP and Rio mine. When it was formed in these ancient river channels as a sediment, it then metamorphosed, and then basically, if it was soft enough for the outside worn down, where you get your mesas that were mined in the eastern Pilbara, and typically the Yandy-Coogin are where the iron ore stays in the ancient riverbed, which is then mined as a open cut pit. Typical Australian iron ores, these are the banded iron formations of the Brockman, the Marramamba. As you can see in these small little, now I don't expect you to read all this, but I'm just giving you a table where you can see the differences pictorially for the low phosphorus Brockman, high phosphorus Brockman, competent dense Marramamba, and the fibrous ochreous yellow goethite. It's got the chemical grades here as well for your information, as well as typical lump yields from each of these types of ore, a little bit on their key attributes and whether they're beneficiated or not. This is the CID, as I mentioned previously. So broadly, the 4 main types of iron ore in the Pilbara is the Brockman hematite, the Marramamba hematitic goethitic ore, the channel iron deposit goethites or pisolithic limonite, and the magnetite, which is a more recent challenge that's come along in the last, let's say, 8 years or so. About that in a moment. Iron ore uses. Well, 99% of mined iron ore is used in iron making process to produce steel. Steel is used in everyday things like paper clips, to buildings, to bridges, to locomotives, etc. You've probably got some steel on you now in your pocket with your keys or your watch, although most of them are smartwatches these days. But even you may have some in your bionic knee that you got playing rugby. Globally, steel is the most used metal by both tonnage and purpose, and 1,869 million metric tonnes of steel are produced in 2019. 53% of this is in China, and the next biggest is in India at 111 million metric tonnes. As most of you probably already know, iron making is used as a blast furnace where you have your iron ore concentrate, your sinter or your direct fed lump into a blast furnace along with your reductants of coal and coke. Basically produce a hot metal where you then put it into a basic oxygen steel making to make your raw steel into steel treatment pots to add your alloys to give you a refined steel of lots of different varieties and uses. You can see the top picture here is the tapping of a blast furnace, and the bottom one is the slabs of steel being rolled. Obviously the steel girders here is a very important thing in modern industrial society for buildings, that's because it's so strong. The other thing I'll touch on is the process of iron ore. 70% of the Pilbara iron ore is a direct shipped ore, or a DSO, which is just really simply crushed and dry screened to produce your two products, which you then export and sell. 26% of the Pilbara iron ore is washed to produce a DSO, and simply crushed, wet screened and deslimed to increase the grade to anywhere between 58 to 63% Fe. Only 2% of Pilbara iron ore is beneficiated to produce a DSO, and again it's just crushed, screened, and then you have your dense media separation in drums, dense media separation in cyclones, deslimed, and usually has spirals as well. Of more modern times is about 2%, or roughly 24 million tonnes in the Pilbara, is now magnetite, which is produced to a fine concentrate and has to be concentrated up using crushing, wet screening, milling and magnetic separation. And this is a map which shows you where some of those processes and different processes take place. The other thing of interest is the evolution of iron ore beneficiation in Australia, and I won't go through this in all this detail, but really in 1966 it started with DSO ore. In 1980 the Newman and Tom Price heavy medium plants were built based on the Scission South African processing plant, heavy medium plant, designed by Mitchell Kotz and I think constructed Bechtel Pacific. Anyway, that was 1979. I know because I was there commissioning it up in Newman, and it was great fun. In the 1990s, Goldsworthy had to upgrade their ore, so they put in some jigs and spirals. In the 90s to the 2000s, basically we had to wash some of the ore to get some of the 15 micron material out to increase the grade, and then along came FMG with their plant to try and upgrade some of the Marramambas, and similarly Roy Hill plant, which by the way has a 75 million tonne input for a 55 million tonne product. And then the other beneficiations, magnetites. In fact, Australia did process magnetite in Tasmania at Savage River, 2 million tonne plant back in 1966, and nothing much really happened until another small plant was put in by One Steel with HPGRs and magnetic separation, and then Sino Iron Ore with City Pacific came along and put in their big plant up near Karratha. Then you've got Carrara and Jack Hills, adding to the magnetite ore percentage. Processing iron ore. I thought I'd give you a little brief of some flow sheets and with a few pictures, but basically just to give an example of a DSO plant, direct shipped ore plant, where you have a primary crusher, you have some scalping screens, primary scalping screens, where the lump is secondary crushed, and then it's all put through product screens to produce your lumps and fines. Lumps come out here and your fines come out here, and then you train load it and send it to Port Hedland in the case of BHP. The top right picture here is the large screening building in Newman, the Newman hub, with the scalper screens and the product screens. The next one is the Jimble Bar, BHP again, with scalping screens and product screens, all dry screening DSO. And this bottom picture is mining area C, again where they put Maramamba in. The top two are Brockman, by the way, and you can see the rail loop in the background. The washing and desanding, desliming plants are part of the process I explained before, and very simply, again, you dry crush, you might do a bit of scrubbing and wet screening. You tertiary crush that material in lump as well to produce your lump product, and then the fines is usually desand or deslimed to produce a deslimed fine product. This is a section of the Roy Hill processing plant. We can see the -1 millimetre after it's wet screened comes into deslimers. You then go into upcurrent classifiers, and then you put it through some spirals to produce a intermediate fine, which then goes back in to join the coarse fine material. Top picture here is a FMG plant where it comes in dry, it's screened and split and goes to a wet plant where it then is deslimed. The bottom picture is very interesting. This is Roy Hill's plant, Hancock Mining, and you can see in the background a huge plant, as I said before, about a 75 million tonne feed input for a 55 million tonne product. Probably more like 59 million tonne product now with this WIMS plant. But in this plant here, again, they simply scrub, wet screen, put a lump product out and a coarse fines product and take the -1 as per this diagram here into beneficiation. The large pink plant here is the WIMS plant that was just put in the last 3 years or so, where they're picking up the paramagnetic material and adding it to the product instead of putting it in the tails. This is a DMS plant, dense media separation beneficiation. Again, dry crush, primary, secondary, dry screen, lump goes into Wemco drum separators, the fines go to wet screening, deslimed and spiraled, and the coarse fines are DSM cyclones. Again, this is a picture of the Newman Benny plant at Newman, which, as I said before, was put in 1979, similar to the Tom Price one. And you should all recognise this one here. This is the Cision beneficiation plant, which both the Newman and Tom Price were designed off. And the last one here, the magnetite concentrate, is a bit of a flow sheet, I understand, for the City Pacific plant, where you primary crush, secondary crush, HPGR, wet screen, then you ball mill, fines grinding mills, and then magnetic separation in here to pick up your magnetite. And there's some scalpers and stuff over here, but basically end up with a magnetite concentrate. My understanding is the design for about 95 million tonnes of feed to produce about a 24 million tonnes of high-grade magnetite concentrate, which gives you, I think I worked it out to about a 25% yield, but it's 66% iron. All right, and one of the last slides here is the major iron ore projects in Western Australia. This is, I thought, would be interest to sellers of mining equipment and process equipment. From about 2013 to 2021, there's been a lot of projects here, both BHP, Rio, FMG, Atlas, Hancock prospecting. That a lot of money being spent and a lot of tonnage for the export of the 900 million tonnes I spoke about. I think Robe River, the committed ones currently, Robe Valley, sorry, from Rio has been done, and the Gaudia one's still happening. Iron Bridge is the new magnetite mine being put in by FMG. Big numbers here, $4.6 billion expected to be spent for 22 million tonnes per annum. Obviously, you would have heard worldwide there are other projects on, for example, Simandou and Nimba up in Guinea, north of you guys in South Africa. These have been on the cards, as you know, for the last 10, 12 years. Still haven't really got off the ground, but they, in my view, will be the next big projects when and if they get going to supply the iron ore into the China and Southeast Asia. So in summary and conclusion, iron ore, currently the global demand is 1.6 billion metric tonnes, with China taking 53% of this seaborne trade. Top 3 global suppliers are Australia, Brazil and South Africa. Global production is estimated at 2.4 billion metric tonnes, with 800 million metric tonnes retained internally for the domestic steel manufacturing. Demand is expected to continue at this rate, with prices expected over the $100 per US DMT for CFR China at the 62% Fe iron ore for the next few years. Global resources are huge, estimated 160 billion metric tonnes of proven deposits. Geology, most iron ore is typically found in sedimentary rocks, and as I've said already, a lot of it is the good hematitic ore. Commodities, well, this is iron ore is obviously used for steel making. Many types of process in the world, but most common is the direct shipped ore. And globally, there's still some major projects forecast in the future to sustain this huge amount of iron ore that gets used in the world to produce steel for industrialised countries. Thank you very much for listening. I hope it's been useful. I hope you've spotted some areas where you can concentrate some of the sales and have a bit more knowledge to promote those. Bye for now, John.